All right, all right. Yeah, good speech before me, and I think I totally agree that we need a good UI and a good user. And but another thing is also important that you need to deploy your service in a totally entirely decentralized network. So unless they can ban your beautiful app at any time they want, right? And so so before I get started, I want to do a small survey. How many of you guys are developers? Please raise your hand. Oh, we have some guys. Yeah, good. And how many of you guys have written Solidity? Smart contract like Solidity? Just the two guys? Okay. How many of you guys have written backend program? No matter what program language you use. Yeah, no. Okay, it's almost good, and at least you guys have written some smart contract, and the difference between smart contract and backend program is that when you write a smart contract, especially in Solidity, you can't access the internet. Of course, it makes sense because all operation must be deterministic. And when you write smart contract, you are hard to do the heavy computation, and you cannot store a mass of data in your smart contract, right? It's very expensive. So today I'm going to introduce a fight contract that built by our team. And I first will introduce what the fight contract is and what problem it serves, and then I will give you guys a typical example of building with fight contract. Is we're going to show you a Oracle, and we have built a non-code Oracle, and you can deploy your Oracle in 30 minutes. Okay. About me, I'm Wenfeng from Phala network. We are a pirate chain from the Polkadot ecosystem. And okay, here is my Twitter, Telegram, and also GitHub handler. If you guys have interesting, and welcome to discuss after the meeting. Okay, so we know the challenge of building with smart contract, right? We write smart contract, but it's really hard to do. It's very expensive, right? Whenever user interact with their browser with the MetaMask or other extension, they must pay something, especially on Ethereum. They must need to pay $1,500 per transaction, and it's very expensive. And it also you cannot do the heavy computation. You just in most cases, all smart contracts just transfer assets from one account to another account and store a little of stuff in your smart contract. And it's so every smart contract looks like very simple and very tiny. We cannot do it very heavy. And the last thing you can start a mass of data. For example, you can't store an image or you can't store a video inside your smart contract. It's impossible. So I have IPFS, and another thing is that you nearly impossible to access the network. It's impossible to access the network if you write Solidity, and sometimes you want to get some information from the Web2 service like Twitter, Binance, and so forth. For example, you want to get price data from the Binance. You want to get a Twitter user profile data from the Twitter API through the Twitter API. It's very hard, and somehow you can use the service provided by Chainlink, and to interact with your smart contract, and you add some request to their smart contract, and they request you some data. It's kind of a Oracle actually, but it's hard because first Chainlink only support a bunch of platform, platform actually. They cannot support other platforms like Substrate, etc. Yeah. So it's very hard to build smart contracts so far, and so we all know the next frontier is off-chain because we cannot do many many complex stuff in on-chain because on-chain logic or on-chain operation must deterministic. What deterministic is, every operation must be can be run by any other validators, and they must get the same result at any time. So one validator maybe runs the operation today, and another validator or another computer, one day they fetch the blockchain data, they run the transaction, validator transaction, they must get the same result. But if you, for example, if you think about it, if we have a HTTP request, we get my Twitter followers today, get my Twitter followers inside the smart contract. Today I have 10 followers, but maybe tomorrow I have 1,000 followers. So it's changed. So it cannot be embedded in smart contract. So that's the generic smart contract or ordinary smart contract work. So we put it on off-chain, but here is a diagram that shows the current technical stack of current dApp. So as you can see, first, every dApp, they have a website, right? And to make user interact with their smart contract or their application. And yeah, most of them are smart through MetaMask or other browser extension. And then they have the asset layer. Asset layer, that means we deploy our smart contract on Ethereum or other blockchain like Polygon, Polkadot, Solana. We call it asset layer, and somehow you need some indexing service like the graph or subquery or any other indexing service. It is also decentralized. The graph, like the graph and the subquery, they are both decentralized index service that can store your on-chain data into a database. Then your front end can both interact with your smart contract, but sometimes, like I say, your smart contract just keep your smart contract very tiny, so it can more cheap. But somehow we need some data that accumulated by many other components. So we need the index service help us store them in database in advance. So our front end can access at any time they want. And we currently when we build the app application, we, for example, even Uniswap, they cannot build everything on smart contract, right? They also have backend. They also have some backend deployed on AWS or other. I don't know where they deploy, but some kind of like this, the Web2 cloud service, right? And they deployed on the Web2 backend, and somehow they need to like fetch the asset price or store something on other place, like store something on Aave or Faircoin, or they get the data from Binance or Google. And but the question, but the problem is the government or the other regulators, they can ban you at any time once they don't like you, right? For example, the Binance and the Coinbase, the SEC just sued them. And so maybe one day they just ban the Binance and the Coinbase in America. So we can see it, so the only way, I think the only way to serve those kind of CEX, right, the central DEX, is build their service on a totally decentralized network. So no one can ban you and no one can cage you. And so far, government hasn't banned you is because you don't big enough. But one day you big enough, they will ban you. And so what we need actually, if we build a Web3 app, what we need actually is, I think, first we actually need a beacon, a place that is secure, because many of the time we deploy our beacon on a Web2 service, we actually will insert our private key. We have a authorized method, and to set something into our smart contract, so we get our private key into it. So, but we first must make sure we have a very secure, totally secure environment that can keep our private key safety, and even the host operation system cannot access it. So first is security. Security is always the first one. And another thing I think is very important that it must decentralized, and you cannot all servers cannot be deployed just on one server. So what if the server is destroyed and whatever the AWS service is down? So we have seen too many things happened on our industry that the applicants just cannot access because the service is down. All right, so we'd better to deploy our product on a truly centralized network, and of course we need our program can be verifiable. So because as a Web3 application, everything you done should be verifiable. But for now, just all our smart contract can be verified on chain, and but our service behind the smart contract or backend service, people cannot know how it works. So here is some magic happened, right? So it's better to have that your program can be verified at any time, even your backend service. So that's why we have the FAT contract. Actually, the FAT contract is a replacement of the Web2 backend. We solve those problems by, for example, all our programs are running inside a secure enclave, which is the security is guaranteed by the CPU, the hardware, and even the host operation system cannot access it. And your smart contract, you derive your private key inside our FAT contract, and it will never reveal to the outside world. You can keep it safe forever. And another thing is, it's truly decentralized. We have I think more than 10,000 workers on Phala network. So it's a truly decentralized network. You don't need to care about the crash. You don't need to afraid of the censorship, right? And it's anti-censorship. And of course, we have provided many toolkits that can connect the blockchain, like the Filecoin or the Ethereum. We have a entirely toolkit that can help you write your smart contract and send transactions to the blockchain or read the data from blockchain. Yeah. Okay. So FAT contract actually is we call it a smart contract because we actually write FAT contract like how we write smart contract today, but it's more smart because, like I said, it have many features and abilities that the traditional smart contract cannot have. Here is a QR code, and I think you can just head to our official website. It's just remove the bricks. Okay. Okay. Here is the feature that can be highlighted on FAT contract. First is it's omnichain compatible. That means we can access every blockchain. Actually, if the blockchain has the RPC service, we can access it. So both UAM substrate or other blockchain that are not based on these two technical stuff like maybe Solana Linear, etc. And internet connectivity inside our FAT contract. So remember, you write smart contract, but you can access the internet. You can send the HTTP request to the outside world, to other blockchain, and so it's just enabling seamless integration with any Web2 API, right? And arbitrary complex logic, you can do whatever you want to do inside FAT contract. Do heavy computation, do a very complicated algorithm, but You cannot do it on smart contract like Solidity. Okay, and the next one is verifiable computation, right? And we must make sure that as a Web3 application, we must make sure that our program can be verifiable. So someday your customer or your user will challenge you and how your program worked. If you had it into a Web2 server, you cannot explain to it. So we need to make sure everything is transparent, trustless. So because our program are running inside the secure enclave and the program log can be verified by anyone. So this is how the amazing features the fat control have. Okay, and another thing that I want to see is writing a off-chain smart contract. With the fat contract actually is a off-chain smart contract. It's not a on-chain smart contract. And so write a off-chain smart contract is it's not easy actually. As a developer, I know that it's not easy. So we have provided the top 2 modules and to mitigate the barrier for developers. For example, we have the file bricks. It's an individual predefined components of file contract. So we actually have implemented many components that you are used in your smart contracts, and you don't need to write it again, right? You just use the components that we provide. But if you are not a developer, even you don't become a developer and you are maybe a PM, a product manager, you also can use the blueprint. The blueprint actually is it's a no-code platform to play the file contract. So if you want to deploy some file contract on our platform and you want to build a product, you actually even don't need to write a single line code. So today as the example that I will show you is the Oracle that actually is built based on the blueprint. Okay, here are some use cases that very typical use cases and our file can build with file contract. The first one is the cross-chain DEX aggregator, and the first is I have seen many times that our file contract can send HTTP request to the outside world. This is the main difference between the file contract and other smart contract, traditional smart contract. And so when you build a cross-chain DEX aggregator, that means you will first swap the asset on first blockchain, and then you swap the asset on the second blockchain, and of course, on the middle, you need to bridge the asset from one blockchain to another blockchain. So there are many steps you need to do, but so many steps you need to do it one by one, and make it sound like a atomic operation. So. So the first use case is cross-chain DEX aggregator. You will use those features that a fat contract can provide it. And the second one is a self-founded Oracle. This is the example I will demonstrate to you guys. And so first, of course, for an Oracle, they must have the ability to access the internet, like get the data from the price service or etc. And of course, it needs to be executed automatically. And of course, you need to have some secret that be kept inside the file contract. For example, the Oracle needs to submit the data to you into your smart contract, but you don't need, you cannot allow everyone can submit the data to your smart contract, right? So you have a dedicated account to submit the response to your smart contract, but you must keep this key safe. So here is the magic of file contract. Because we run inside the secure enclave, you can keep the key safe and use this account to submit the data to your smart contract. And the third one is trading boot. And I think the trading boot, for the trading boot, it's important is it can do high performance computation, because as a trading bot, or you have your own trading strategy that somehow it is very like heavy computation algorithm. So you can't do it on a smart contract, right? So but you also cannot do it deploy your deploy your boat on a Web2 service, even though you guys are do it right now. But I highly recommend you to move it to a decentralized network, and especially your trading boot will also have a key because your boat needs to send a transaction, right? And the DAO control Web2 service is a typical use case, and for now we have many service and running a backend and but the DAO actually some of the I think many of the DAO are just running for one blockchain, and with Fed control you can build a DAO across different blockchains. And the last one is trustless ranking system. Of course, I think they don't have too much difference under the hood, and but it's really the ranking system maybe it's a high quality, needs the high quality of the computing performance, because somehow you need to get the result as soon as possible. Okay, here is a project. It is a project come from our ecosystem and called the Private DEX. It's a DEX aggregator, and it can bring assets from Moonbeam to A star between any parachain, and in the future they will bring their asset, bring their product to the blockchains, and they got the Web3 Foundation grant, and they have I got many funds, I think, and so in Fiat contract we actually can build some product actually. And by the way, I just forgot, and we launched the Fiat contract mainnet just yesterday, I guess, and June 5, so the day after yesterday, okay. The day before yesterday. Okay. So here is let's break it down, the Fiat contract, and what's the relationship between each component. First, we have blueprint, and you don't need to write a single line code, and you can deploy your application. And first, we have Fiat contract SDK, whereas it's like a Fiat log, or it's like a log or in ours, and some JavaScript SDK. And of course we have contract cluster. This is important. That represents that our smart contract actually running in the thing that we call cluster. A cluster is contained by many workers. So a bunch of workers will become a cluster, and the Phala network will have a bunch of clusters. So that's the architecture of our workers, of our network. And each worker, inside each machine, we have the P runtime, the trust execution environment, and so this is very low level execution environment. And so far we support the Intel TE, and in the future we'll support more infrastructure company. Okay, so I just said, and today we will show you a typical example of the Oracle, and we have built a Lens Oracle platform and give you the no-code experience. What the Oracle do is you can deploy your own Lens Oracle through our platform, and it can for this you will deploy we will deploy for you a Fiat contract then as a backend, and a smart Solidity contract deployed on Polygon. So so this is the complete this Oracle contains. And here is the architecture of this Oracle, and I can bring you guys to how it works. At first, as the middle of the diagram, the Oracle, the core of the Oracle is written by fat contract, and it can interact with both the NIS protocol, the right side, and the Polygon network, the left side. And first, your Polygon smart contract, yes, the Solidity contract you deployed on smart contract, you deployed on Polygon network. First, your smart contract can send a request to our fat contract. That means, oh, I will request some lens protocol data. Please give me that data. And our fat Oracle will get this data, get this request, and pass this request and pull in the latest data from lens protocol through lens API. And we pull in the lens protocol data every 1 second. So it's very frequently. And then when after the lens API returns the data, we will construct the response and send a transaction to feed those data to your smart contract. So under this, on this workflow, and the only thing you need to change is the data type in your smart contract, because you can customize what's your data type is. Okay, here we have a demo, and yeah, we can show you, because we don't do live demo in case some network issue. And here, as you can see, this is the UI, and you deploy a Oracle, and first you can choose your project name, right? It makes sense. And then here, actually, you are choose what kind of type you want to get from the NIS protocol, the NIS profile, right? We have a NIS profile. NIS profile have your user profile, and then you just can create an. In case you don't have an account, you will create an account and connect the wallet. And then you just need to click deploy, and we will do everything for you. For now, we will deploy the Oracle backend, writing in file contract, and then we will deploy an example contract that the anchor contract is in Polygon testnet, right? This is showing in testnet. So, and so, okay, oh, just get back. I need to jump to this because I think this is important. So here in our UI, we will show you an example code of how to interact with the smart contract you just deployed, the Oracle smart contract. And in case you can see it, and so I will show you the live code. Here is an example of your application. We just suppose you already deployed all of this stuff just now, and now you have your own application, your own smart contract that you can read and write request from the Oracle. And let's see how it works. First, we have a request method, and that means you can send a request to our fat contract, the fat contract Oracle you just deployed, yeah, inside our network, and you just construct the request, and then you, for example, here we'd like to the profile ID, and we encode it and just call the push message, and this function is come up with the fat rollup anchor smart contract. It's provided by us, and you don't need to care about this. You just need to push this message. That means it will push a request, and the Oracle backend will observe this request and pull out the data from the NIS protocol. And after our smart fat contract, Oracle smart contract have got the data from NIS protocol, it will feed the data to your smart contract, and you can handle the data inside your smart contract. This is your customer smart contract, where your application logic have. And as you can see, we have the response type defined by you, and you decode it, and you just do whatever you want. Here we just emit an event, so it's very simple. But you can do everything you want inside here. And this is the smart contract. Then this is your smart contract. You can write in your own logic. And here is the implementation of our off-chain rollup, the Oracle side. And so as you can see here, we have a function called answer request. So you guys just know how it means, right? You just send a request from the Solidity side, and now we will answer the request inside the file contract side. How it does, and first it will destruct the request data, and then it will, for example, answer request. If we dive deep into the answer request inner, we can see it will decode the request, and it will get the data, fetch the length API, from the length protocol, right? And then it will get a result. It will get a result from the length protocol, and the last one is when the result is okay, it will just okay, we have a result, and we just send some transaction here. Maybe submit theta, that means we will send a transaction to the Polygon. You just deploy your Solidity smart contract, and we'll return the data for you. Okay, so here is the implementation, and yeah, we just have a simple review of this. Okay, so the video is done. Actually, we almost do all of this stuff within. Actually within 1 minute. Actually, yeah, it's very simple. And okay, okay, yeah. As I have said, we just launched the mainnet, and we have a builder program, and the program, we have a program pool, and every team can apply at most $15,000 for every team. And everyone, if you like to build something with file contract, just scan the code and get the details. Yeah. Okay, and here we have some QR code for the I think very useful page. For example, the first one is the awesome file contract GitHub repo. It contains many examples file contract, and the middle is Phala network official website, and of course you can get all the file links here. Okay. Okay. Thank you. Any questions? No. Okay. Thank you.